To begin.
Yeah.
All right, great. So, first of all, you guys did amazing stuff, like really amazing stuff. I I wasn't kidding when I said somebody wrote a code to mine Bitcoin. Okay, maybe I was joking, but you know, it's really nice what I saw people do today. So I'm just going to make a couple of general observations. So I'm going to be saying this with, I'm going to keep in mind that Ikene and others are going to get an opportunity to watch this video, which means that I'll also be referring to some of the works that they did, right? Excuse me, let me get to this site. I'm sure by now most of you have seen the scores. And like I said, it's not a the scores are in no way a measure of your skills as a programmer. In fact, they don't mean a lot. They're just my own projection of what I feel you should have done, which is very rigid. But as you start to develop your own way of programming, to start to show, and it might even be better than mine. Not it might. In fact, that's not the word. Better. It will be good, and the most important thing is that your code works and it works well, efficiently and effectively. Efficiently means that it minimizes resources. I mean, not all programs require that you need to minimize resources. They all require that they work. Your code has to work, definitely, but not all of your code not all your code needs to minimize resources. But then you might have to get to a point where you need your code to run very fast while minimizing space that's using on memory. So, all that are just advanced. But like I said, as it gets better, your style of programming will show. So, first things first, Ubina and Peter, since you guys are here first, I will probably start with your codes. Let's take a look at what sorry, Peter and Dami wrote. Right. So the BMI calculator was pretty straightforward, I think. So let me make yeah, the BMI calculator was pretty straightforward. This is Peter's code. As usual, I'm going to send all of this to the Google Drive so you can all have access to it and then compare with your code, see what you could have done differently and all that. So this is Peter's code. This is quite, BMI the BMI question is pretty simple. It's pretty straightforward. I see some of you already like going advanced. Some people are using if and else. Some people are using try and accept. So like, damn it. It is what was it? Try? I think it was yeah. Oh my god, it was huge. But this is try and accept. Like that's amazing stuff. I think Pythagoras, somebody shot me with something. Let me quickly check. Nope. Gideon hasn't submitted yet. Oh, okay. Maybe I was just wrong. Oh yeah, it's Peter. But we'll get to that. So this was amazing stuff. You guys were using crazy concepts that I've not even gone through yet. And that was cool. I like that. I like that. Um. Oh. Okay. So like I said, BMI, right? So this is Peter's BMI code. Pretty straightforward. No, sorry, excuse me. He used an if and else to interpret your results. Now, I was going to add that in your BMI, you should also interpret the result, but I figured as if we haven't done if and else, let's not go too far. But it seems like Peter grasped the idea. I don't think that me used an if. Oh, he did. Wow. Look at that. So it looks like none of you grabbed the idea. So this coming week, when we're actually going to do a conditional, I don't think you have a lot of problem. However, one of the things I noticed was that let me show you something real quick. Last week we dealt with boolean no, variables, casting, and data types. Now inside here you're going to have to work with booleans and expressions. Well, last week we dealt with this week we dealt with expressions. Now this one and this one, they have interwoven prospects. Like I said, they are building blocks. As you go on, you start to see how your code can become, better, faster, whichever. Now, one of the reasons for some of the assignments I gave you was to make sure that you're able to maybe to mix those two together. Essentially, let me use the wrong English, and I think I expected that mostly here. The only person who did something of that sort was Dami. I guess I could see I guess I could see his thought process while he was coding. But we'll get to that. I'm just trying to go through like a general overview first before I have to go specific or anything. So yeah, it's amazing stuff. You guys did really well. I think one of the things I will also say, and I tried to explain this last week, is learning how to break your code. I explained that when your user is entering a lot of data, it can get overwhelming sometimes. So you should learn how to categorize and use inputs to hold at some point. It was very exemplified here because in the Pythagoras theorem, rather, because you're collecting about I think eight coordinate points. That was a lot of information, and your user can get really tired really fast. I think Obina came closest when he did this. You know, he printed out. Let me run it. I think I don't want to do this. He printed out this part first, so you know they are dealing for A, right? And then enter values, and then it stop again. You print for B, you enter the values. So you're basically seeing your process as you're going. But then if let's use this for instance, I'm just going to clear this and then run it again. If you had this is the approach somebody is. I don't know whose code this is. So you have to enter. See how it beats cumbersome really fast. You get ignore the error. But you see how it gets cumbersome really fast because you're basically entering information. And I mentioned this last week when we were dealing with the chatbots that you can get quickly tired of inputting information. So you want to make life easier. This is just a user experience thing. You want to make life easier by presenting information one step at a time. A very common theme that people use is press enter to continue. Press enter to continue. So you show this. So a common theme would be show the title of the code, Pythagorean theorem here. Then you can show press enter. Or no, you can show the description of what your code does. You can say stuff like this code calculates the distance of this and this using the this and this. You know, just something brief. Then you say press enter to continue. So that way you've introduced them. Then you let them sync that thing, and when they're ready, they press enter. Now you press enter. You say, okay, I'm going to get the coordinates of A, for instance, A1, and then they enter four information at once. You hold, you acknowledge that you've gotten information, and then tell them you're about to enter for B. They enter the next four, you hold, and then you acknowledge that you've gotten information. So that way there's a bit of progress to it. If you're dealing with more graphic user interface, a way of acknowledging that you've gotten information would be like maybe since you have the 2 point, maybe drawing a line on the screen so that they acknowledge that okay, this is what exactly what I want. But like I said, all of that is UI UX. It's not pertinent to your code. It's just something that would be nice to include, making sure data is not overwhelming for your users. I think Ekene is still. I'm not sure. I'm not going to tell him not to do this. I'm not. Oh, yeah, I'm not going to tell him not to do this. I think it makes his code easier for him when he's putting it in different lines. But like I said last week, try to minimize the lines of code so that way it doesn't take a lot of space. It's not, again, for this early stage, it's not absolutely important, but you know, it will be something to know along the line. Damis try and accept was perfect. And I think what he did with try and accept, Peter did here. Let me look for that. I think yeah, here. I think this was very, very interesting about Peter's code because in the assignment for Pythagorean theorem, I said that um, the instructions are not instructions. These are like the laws guiding your code. Come on, don't do that. Let me get the instruction. These are the law. This is rather. These are rather the law guiding your code. First of all, they have coordinate points, and this was something that, even though I said I didn't really expect anybody to code it, but Peter actually did it. Right? Check that the lines are parallel to each other. So if the lines are not parallel to each other, I mean, Peter is an engineer, so he knows that lines parallel to each other have equal slope, and then he went and calculated the slope. If they are not parallel to each other, then there's an error with your input. Not that it's an error with your input, it's just that this script will not work for what you're trying to do. So maybe a message like, okay, the lines are not parallel, maybe find another script or something, which is good. This is perfect. That's a very good way of handling things. Now, this will obviously, if you had not done this test here and you basically ran your code, it might have shown a value, but it will not be accurate, which now brings me to another part of programming that I didn't mention in the beginning. I learned this when I was working with EDX. I think I've shown you guys that course a lot. I should probably just send you the link already. if you ever have the time to watch it. There are three types of error. There's the error where I'm just going to create a new Python script and call it test. Put it on my desktop, call it test.txt. Sorry, .py. And I'm just going to say, okay, so there's something called syntax error. Let me do this. No. Let me do this. No. Sorry, excuse me. I'm just trying to, it's been a while since I did this. So there's something called syntax error. And that one is something, no, let me use IDLE because that's something I'm not familiar with. Most IDE have a way of noticing errors. So they basically have like a superficial understanding of how code should be. Can you guys hear me?
Yes, I can.
Yeah.
My network stopped at when my router went off. At what point did you lose me?
When you're going through your EDX stuff, I think.
Oh, I'm sorry about that. I'm going to try to go back again. But so far, did you understand what I've said?
Yes.
Dami, how about you?
Yeah.
All right. Okay. Let's continue. Let me continue from where I stopped. Right. I'm going to share my screen. I can't believe that actually broke. That's ridiculous. Okay. So something I learned on EDX was that there are three types of error that you should expect. Please, I can't remember. You know what? Let me just quickly do a quick search. I know I had a course on it at some point. It's been a while. It's been a very long time. So I'm not just spinning bands for you guys. Dashboard. Let's go to the course. That's of programming. I think it was like the first few topics. Again. Survey. Python. Let's start here. Just in case there's something interesting off out that I haven't seen yet. Okay. Introduction. Exercise 1. Let's just say I good. I score 5-5. Let me see exercise 2. Okay, I think this is it. Nah, this is not it. Exercise 3. I just want to get the names. They mentioned, I know I have the quiz about it at some point. Exercise 4. Tell me whether the string is legal. Oh yeah, perfect. Semantics, static semantics, and syntax. Perfect. That's exactly what I'm looking for. So syntax, semantics, static semantics. If I can download this video, probably I think this is where it talks about it, the video before the exercise. So essentially, the first one is syntax error. So syntax error is there's a way your code should look without even running. It should look this way. If it doesn't look this way, then there's an error with the code. An example would be, I'm sure some of you know if and else already. So let's say I created a variable, say x equals to 5. And I say if x equals to 10, print x or something. Now, this code is missing one thing. And you can see that because of that, there are like different errors everywhere. And the reason is because of this colon. I didn't add this colon before. And conditionals are not, I'm not going to try to explain this one in too much English, but essentially this should have been 2 equal to not 1. Now, because of this missing stuff, this red line you see, this is a syntax error. That means that I did not structure my code properly. Now, for that, most code editors can identify that. You don't have to click on run before you notice it. If you work with C#, C# does not identify a lot of the syntax error. It's when you start, okay, C# does. I don't know any language that does not actually. Most code editors will notice the syntax error. If, however, you wrote this in a notepad, I'm sure you know that you can write code in notepad, right? And I saved it. Let me say I saved it in test.py. Let me call it test2.py. Now, this will not tell you that there's any error because it's Notepad. Notepad does not have that kind of feature. But if you were to write this in IDO, for instance, IDO will not also tell you any error, rather, because it's what? A Notepad, more or less. However, those IDO would notice there's an error if you try to run Moodle. Check this out. I have to save it first before I can run it. Call it test 3. .py. Try to save that. See the error. It says invalid syntax. I'm sure you see why it's a syntax error. Even though IDO does not, let me move this here. Even though IDO does not recognize, does not do all these red line that Visual Studio Code does. Visual Studio Code is an interesting visual editor, so code editor rather. So it's kind of good for that. You don't have to run your code before you start seeing where the error is from. You can start to see them before you run the code. But if you're writing it in IDO, you wouldn't see that because it's a simple node editor. But when you try to run it, the compiler will do like a syntax check first. If there's an error with your syntax, it will tell you that syntax error, basically invalid syntax. Now that's the first kind of error. Now the other kind of error is, let's say, let me do something like, I'm not sure there's a lot of, okay, I'm just going to use something based on what I've learned so far. I want to use a list. Now, this is a list of 5 elements. If I try to access the 6th element of that list, for instance, and by the time you run that, this will not give you a syntax error. It will give you a syntax semantic error. I think that's what that is, a syntax semantic error. Now, what that is trying to tell you is that your syntax is correct, but then when you run through the compiler, you get an error at some point, meaning that this is not a legit expression because you have a list of more than of 5 elements and try to access the 6th element. Now, one of the ways you can look at it is that a syntax error is not like fixed. Remember before our I'm mixing this up. Jeez, pardon me. Remember before our let me do y this time. Our syntax error. The reason why we had that syntax error is because we did not have 2 equal to here. Now that's a fixed rule. No matter where your Python code is running on, no matter the compiler, if they are not 2 equal to, it will not run. That is a syntax error. I'm sure maybe I'll watch the video and try to have like a session about that later. But then a static syntax error is different because it's basically based on your code. So in this case, your code says that X is an element, a list of 5 elements, but then you're trying to access the 6th element. That is a syntax semantic error. Now, if I were to increase this to like, say, 10 elements, and I run the code, sorry, see, invalid syntax, beautiful. Thank you for making that clear for us. That's because I didn't put a comma here. So when I run it again, you see that this time it didn't show an error. That's what you call a syntax semantic error. Now, if that was confusing so far, I'll try and explain it in another video. Maybe I shouldn't waste too much time on it here. But now that's the second type. Now the final type, which is what I was trying to explain from the beginning. If Peter had not put this thing here, your code might actually have run. You might get a value, just that the value will not be the actual expected value.
Yeah, you're right.
Exactly. So in that case, that now is semantic error. It's not going to be red and then alarms are going off everywhere. No. You as a programmer will know that, okay, this is not the value I'm expecting, so something is wrong. Do you get now? Those are the 3 kind of errors: syntax, semantic, and semantic. I would make a video about that later and provide that for you. The reason is because you want to know that because oftentimes semantic errors are the most difficult to deal with. When your code runs fine, but then the output is very different from what you're expecting. If you have like 1,000 lines of code, where do you want to start finding the error from? Now, if it were a syntax semantic error, so that when you run your code, at some point it crashes, the code will actually tell you that, okay, this is the line that had the error. Then you can easily go and start, tweaking things. That's much more easier to fix. If it's syntax error, that's pretty easy. If you're using a code editor, if you're using a code editor, it will show you exactly where the error is coming from, and then you can fix that. So I appreciate what Peter did here by checking that. And then if you see that, okay, they're not parallel, it tells you that it's an error. So probably look for a different code. Or you can make your code such that you can do something else here. I don't know. It's really up to you. Do you guys understand what I just said, or was I just going too fast?
Yeah, I get the point.
Okay.
It's just basically to really understand, like some kind of errors that wouldn't be, usually visible to,
Exactly.
to the person who is not programming it, or just based on your expectation. You get,
Exactly.
so it just
Exactly.
helps you check that. Yeah.
Dami, how about you?
Yeah, yeah, actually gets it. Probably like I don't know. Some people used to call it like a logical error, bro.
Okay.
Yeah,
Okay.
because like for what he did here, like you
Mm-hmm.
said, the code is going to run, but
Mm-hmm.
logically it
Mm.
is deficient somehow. So
Yeah.
I don't know.
Perfect.
Yeah, some
Perfect.
people used to
That's
call it like logical error most times. So
Thank you for that input. I think this guy actually called the logical error at some point. Now that you say it, I remember that I called it logical error. Thank you for that. So like that's a welcome. Obina is with us now. So that's a major thing. And I currently face that a lot in my work. And you see a lot of programmers post this on their status today. During the coding, the development, they were doing well. They were typing, everything was working fine. Then they deployed it and everything just spoils because most of the time they don't get syntax or syntax semantic error. Just that the output is very different. And that's very concerning for them because they know they have to go home and start from the beginning and start to look at where did the logic, as you say, where did the logic go wrong? You get me? So avoid syntax, semantic errors as much as you can. Those guys are serious. Obina, welcome on board. Obina is not hearing us. Okay, I'm just gonna go ahead. So amazing stuff what Peter did here, and like, it's also important because if I were to take this code and I did not notice this, see, I'm not a big developer like that. I will just take it and I'll run it. Now, if your code is reliant on, is basically supporting heavy systems, like for instance, you're developing a trading system, and your code now makes one stupid mistake. Oh my God. Well, obviously, you know the cost of mistakes when you're dealing with stuff like that. So that explains that. Let me find what the hell is it? Let me get you another general concept, another thing that I picked up. I basically have a notepad with me here where I basically have a notepad with me here where I basically run through everything I noted down. Um, yeah. So another thing I liked was this guy Obina's function with Pythagoras theorem. Yeah. So if you check Obina's code again, I'm going to upload all of this to the Google Drive. He basically had reusable formulas. You notice that virtually all of his formulas were reused somewhere. You see BX, this, and then he places it back here. BY, he places it down here. B, he places it. There should be a B somewhere. Oh, it's just printing it. I guess that's what it's doing. Let me comment that out. See if it has to be using it somewhere else too. I can't see it now, so I can't see it now. So, but essentially, it's having like repeated functions. Now, obviously, somebody else can, instead of having bx repeated everywhere, can just basically copy x4 minus x3 and put it into the brackets here. That could easily be done. Excuse me. That could easily be done, and then do that for everywhere you see bx. But then that can make your code really cumbersome and complicated. But then by doing this, if you want to change the formula for bx, you only have to change it once, and basically your code will do the correction respectively. That's one benefit. Another benefit is that if you were to give this code to a different developer, you understand straight away what you're trying to do because you've broken it down in very clear terms. I'm sure some of you know your mathematics. The way they write formulas, they say let x be this, and y is this, and you get another value for z. That step-by-step process is what it did here, which is very nice. I mean, sometimes it has its detriment, but in this particular situation, it was perfect. Um, I'm sure you can see one of the detriments. You know what, Peter and Dami, from what you can see, what do you think is a disadvantage of doing this? Not necessarily like a very bad disadvantage, but it's just a downside of having to break down your formulas in this way.
yeah, I feel just longer codes, obviously.
Exactly. Exactly.
Yeah.
Just, your code becomes long unnecessarily. And again, this is probably fine. It's just 73 lines for something this small, which I think some other people did in like what 10 lines. Okay, 39. But it's just longer codes where you're dealing with much more complicated problems. Not everything has to be broken down. Sure, some of the things has to be, if you're dealing with a code that say this that is, I don't know, 200 characters long, a formula that is quite long, you'd probably want to break that down. And I'm actually, a perfect example would be, actually Google the longest mathematical formula in the world. I can't seem to find them. I can't only give you guys an assignment, but I didn't find anyone. Oh shit. Oh shit. Okay, looks like there is one. Peter, your mic is on. All right, thanks. This is actually quite a long one. Probably looking confusing too. Maybe no. Okay, this is another long one. This is another long one. So you probably want to figure out how to write how you probably want to break down your code so that you can solve all of this without having to write everything on one line. In that case, that will probably be beneficial. But aside that, amazing stuff. And finally, on a general note, I am not very what's the word now? I don't understand what went wrong with Ekene's variable name. There was a very important reason why I said that you need to learn variable names in the beginning. There's a reason why I said you need to learn variable names in the beginning. Yeah, I think. Okay, yeah, this was poor naming of variables, very poor one. Value 1, value 2, value 3. Compared to others, I think Dami did quite a good job about that. Yeah, X1, Y1, perfect. Because then if I give this code to another developer, I can understand immediately. With Ekene's code, I needed to start checking, okay, value 1 represents X1, value 2 represents X2, and then I had to now start following one by one. Might not have been a lot of challenge in this case, but imagine I was dealing with a lot of lines of code and then I'm just seeing different variable names I don't understand. I don't know if that video told you this, but one of the things your variable name should be, one of the features of variable name should have is that it should be intuitive. So you're able to see the name and understand exactly what it's doing in that code. Now, the truth is that nobody really has a perfect system for naming variables. It's like I said, it's intuitive, which means that it's subjective, so it can be very personal. Somebody can name first name as first name. Somebody can name as name. Somebody can name age as age. I'm sorry, date of birth as DOB. Another can name it as date of birth. They are all the same. Somebody can say date of birth. Another person can say DOB. I assume that these are the most professional ones. People will probably use this because it's shorter. But if you want to go crazy, you can say born day or head day. I don't know. The weird guys that say happy born day, happy head day, or won't be this
That's
day.
funny.
I'm sorry, it's funny people. So it's just up to you. I wouldn't advise using something like this in your code except you want to get a job somewhere else. But try to be professional with your variable names. Make sure that there's stuff that if somebody else rather sees, they understand straight away. I think it wasn't just one time. It was it was repeated a number of times. Yeah, no, I think maybe that's just it. So that's important. Variable names are important. Again, these stuffs are building blocks. You're not going to drop everything you learned from week 0 or week 1. You're basically building on them. Okay, so if you did not understand it well, I recommend you go back to them. If you didn't do the assignment before and you still don't get it, check out the drives. If they're not enough, reach out to others. If that's not enough, reach out to me. But they are building blocks. The moment you miss one, you probably miss a lot more. So I think that's everything general. So you guys did amazing stuff. Now, Pythagoras theorem was pretty. Yeah, I think Pythagoras theorem and the age calculator were like the most difficult ones there. With the age calculator taking the cap for that. But before I go on, do you guys have any questions? Dami and Peter. Okay, let's see in the chat. All right.
No.
Dami, how about you?
I didn't get what you said.
I said that before I go on, I'm about to get into the next stage of reviewing this stuff. If you have any question, now will be the time.
No, no.
All right, great. So I'm just going to review the two assignment, Pythagoras and age calculator, age calculator extended. So the Pythagoras theorem was, it's a law of English, and one of the reasons why I included that was because if you're going to apply for jobs online, they'll probably tell you to go to Akarank. And Akarank writes a lot of English, a lot. Like you need to basically dissect all the English to see exactly what they're trying to say. So it's probably I'm trying to trying to make you get used to the concept now. So it's not foreign then, and it's actually quite good when you know how to look at a word, a whole paragraph, and then try to. This one is even simple. Look at a whole like couple of paragraphs and then try to figure out what the problem is there. You know when we did our programming here, so that's our lecturer gave it to us. And the reason is because oftentimes I imagine in a properly structured organization that's big, they have projects. I'm sure Peter understands how project was a PM or aspiring PM. They have projects and you have stuff called project charter. You have stuff called I've forgotten Jesus. Project charter. What's the other one that they use in that planning and design? Like a project document, yeah. And they have a list of functions and everything. And all of these stuffs are literally written in English. And they're not just one line, two line, three lines. No, some of them are whole documents. So as designers or as developers, you have to know how to take those documents and then convert it to actual code that you're going to write. Because I mean, in those documents, they tell you what they're trying to do, they tell you the limits, they tell you the errors, they tell you everything. And so you're supposed to take all of that and then convert it to code. I'll try and look for, hopefully by the time before we're done with this entire programming Python basics part one, I will try to look for something like that that'll make you familiar with that. So Pythagoras theorem was quite wordy. I know that. But I do appreciate the fact that everybody, which I noticed, everybody was basically doing a research on how to find the length of the line. Sorry, I keep moving this shit. So I'm just going to create a quick picture using my PowerPoint. Did anybody notice something weird about their Pythagoras theorem, especially about this? Output the length of the diagonals between the parallel lines. Anybody noticing anything weird?
Sorry, I think I lost you for like a second.
Okay, I would say that again. I asked if everybody noticed anything weird about this particular part. Output the line of the parallel. Are you kidding me? Output the
Yeah, that
line.
particular,
Okay.
the last stuff where you had output the length of the diagonal between the parallel lines A and
Yep.
B.
Yep.
Yeah. So I think in our last discussion where we had a review, I know I mentioned that. So
Yes.
basically, I was guessing that should just be probably the two longest line along, which should also be like the length of the two sides of the difference between the two sides, basically.
Okay. Awesome. Awesome. Thank you.
That was
So
it mathematically anyway, sure.
okay. Thanks for saying that mathematically. Dami, how about you? Did you notice anything weird while you're doing this?
Yeah, I was trying to like actually see if it's possible to find that length based on the discussion we had the last time, but like I saw that it wasn't working. Like I've not seen any mathematical way
Okay.
to
Okay.
solve it. Yeah.
All right. I think you did well. Oh, before I forget, Dami's use of the function round was good, was top notch. Because what that did is it made your code more fancy, easier to read. I actually don't know numbers. I just put random numbers here. Hopefully it doesn't crash. It didn't. So obviously this is a ridiculous number, but I just I just guessing, yeah. 48.72. By rounding up to two decimal places, it makes his values look more fancy. So this is just something that you guys should know. If you want to make your stuff, you want to round it to decimal places, you use the function called round. and then put the number, whichever variable you want to round up, and then the number of places you want to round up to, either 2 or 3 or 4. So experiment with that and then use that in your future code. So moving on.
Nice.
You're welcome. Moving on. Yeah, I want to quickly show you something. So I'm using PowerPoint. I couldn't find any software online that I could use as a Cartesian thing to explain my thoughts. I work with PowerPoint a lot, and I think it's the nearest thing to help me out with this. So assuming this from here to here is line A, right? And I color it black, I'll weight it to be, say, 2.5. Now this is line A. Now, obviously, the condition says that they have to be parallel. So I'm just going to create a duplicate and make it parallel to each other. Now, to get the length, obviously, this is pretty straightforward. I'm just going to run through it again. You draw a line up like this. Draw another line. I'm doing this mathematically. I'm not programming you or whatever. And then this would be a whatever they call it now, right angle triangle, and then you know the x coordinates, the length based on the coordinates given to you, and then I'm sure that's what you all did. I expect that's what you all did. I don't have to explain all that to you again, right?
Yeah.
Okay. Now that's how you calculate the length of each of them. I'm just going to move this away. They're still parallel to each other. It's just that they're not facing each other anymore. Let's assume that one of them has a longer length than the other. Now, would the diagonal now be this? This is where the issue was. Is it the diagonal we're going to get, or this one? Now that is okay. Peter has something to say.
So I want to make a comment. Both of them
Alright.
actually diagonals. You understand?
Okay.
Although, just like it,
Peter, I think I lost you for a minute.
so can you hear me now?
Yes, I can.
Said both of them should be the diagonals. Although, as I said, they are meant.
Peter, we lost you again. Peter? Damn it, do you have something to say? While Peter is
No,
recording?
like looking at this now, I'm looking at, okay, it's actually possible to calculate the distance since you just know the points. But the thing is, they are not on the same line. I'm just looking at, okay, but still you can use the, like, you can use except I want to do Jomo. Yeah, because I feel like, yeah, since you know the start of a point, yeah,
Okay.
and the end of a point, since it's a straight line, you should
Okay.
be able to use those two values, those two coordinates to get
Exactly.
the distance.
Exactly.
Yeah, which makes sense now. Now it makes sense. No.
Because
Because I was like waiting. I was just like trying to like find out that problem. I didn't think of it that
Oh
way.
my
It
God.
makes sense.
Yeah. Amazing. Peter, I think okay. Welcome back. You don't have any problem anymore, do you? Peter? I see you're talking, but
No.
okay. All right. So Dami just gave us a very extensive explanation of how to get the diagonal. You were trying to say something before your network interrupted.
Yeah, okay. Can I listen to the explanation, please? I don't know if you can go back.
Okay.
Just
Dami, could you go over it again?
Okay. So what I said is, since they are straight lines, yeah, you can just take the beginning of the 2 points and use their coordinates to calculate the distance between them. So we don't need to be doing that typical Pythagoras theorem stuff. It's just the same way we calculated the value for line A and line B. since they are straight lines, regardless, you can just take the value of maybe its coordinates is x3 and x and y3, and this one is a2, sorry, x2 and y2, and use it to calculate that distance. That's all. That's why I said no.
All right.
Oh
Thank
yeah,
you.
yeah. That's interesting. Yes, yes.
Okay. So, do you have anything to add to it?
No, I'm good. I think let's just listen to how we should.
Okay. So, um, exactly. So we all know the formula for distance between 2 points. It's square root of x y2 minus y1 plus square root of square root of y2 minus y1 squared plus x2. I'm sure some of you know that already. I don't have to start, but just for the sake of formula for distance between 2 points. Should be straightforward. I need something that is more. Yep, that's it. X2 minus x1 squared plus y2 minus y1 squared. Yeah, and that will give you the distance of these two diagonals, which is fine. But then one of the things that I would want you to be careful of is the definition of a diagonal. At least that's what I thought it was anyway. What is a diagonal? All right.
Yeah.
Okay, let's not go into English. What is the diagonal is basically saying, it's a parallel line. Even though it has a start point and an end point, it is not a quadrilateral that is enclosed. A quadrilateral is this, as it has an enclosed shape. Parallel lines don't have enclosed shape. They're basically two lines. Let me get rid of this two. They're basically two lines that don't meet each other. Now, when I say the diagonal between the two of them, I need to point out that I'm not actually asking for the distance. These distances. I'm not asking for that. No. So let me. I know that might have been confusing. I wasn't asking for this distance between the two of them, even though that's quite possible to get, as Dami has pointed out. What I was asking for is diagonal. Now, the rule for diagonal is it is exactly at 45 degrees at the corner or whatever. I don't know if you get what I'm saying. Now, to get the diagonal of this, what I would do is I'll first of all draw a line that goes at 45 to these guys. Let's see. That goes exactly at 45. Does this look 45? Yeah, I think this looks like 90. So not 45, that is perpendicular to it.
Yeah.
Right?
Interesting. That was it. Yeah. Okay.
Then I draw another one here. So let me just copy this guy. Another one here. Now I'm going to get rid of these two. They're getting too everywhere. I'm just going to get rid of them. I'm going to extend this line a bit more. And I'm going to move these guys forward because I'm getting to the edge. So let's get there. So we have two lines like this that are basically perpendicular to both lines. Then the diagonal will be the line joining those corners from here to here. Do you see it?
Yeah, yeah.
This will be the diagonals, not from the edge to that edge. And it's simply based on the fact that even though I gave you the start point and the end point, diagonals, when you deal with parallel lines, they don't touch. So they're not quadrilaterals. Quadrilaterals have diagonals that go from corners because they're enclosed. Triangles, not triangles, rectangles, pentagons, whatever. They have diagonals because they're enclosed. So when I see diagonals using parallel line, I don't figuratively mean from here to here. I'm basically just saying the line that is at 45 degrees to two of them. And that's what this is. Now, if you check something funny, no matter how you move these things, they will always be the same. You see
Exactly.
that?
Yeah.
I'm sure some of you know the idea of locus. The idea that when you put some things in place, no matter how you move other things, it will always be the same.
Yeah.
Another example of locus is, let me see. You have, what's the locus of a point? This is 1 point. This is, damn, are you with me or are we confusing right now?
It's not
Are you?
difficult to. No,
It's not
I'm just.
difficult, but good, very good. So let's assume these are two lines. Locus is wait, is it Kenny still with us? Hey, Kenny, how far now? Can you hear us?
Yeah, I deal with you.
Do you understand what we're doing?
Yeah, definitely.
Awesome, awesome. So just to give you a bit more insight into locus, say these are 2 points, and they say what's the locus? Sorry, what's the locus of this point? Assuming this point is fixed, and this point is allowed to move around, but then the distance between the 2 points are also fixed. What is the locus of something? I don't know how they say it in English. The idea is that to create a circle such that let me see, let me change transparent. This thing is not. Those stuffs are better drawn with what they call them. Let me make it centered. Align center, align middle. Good. Align this one to center. No, align it to middle. Align it to the left. Maybe to the right. Awesome. Okay, let's just move it a little to the edge of the circle. Yeah. So assuming this, let me just get rid of this guy. Assuming these 2 points these are 2 points on the plane, and then this one is fixed, and this guy is allowed to move, but then it must be at an equal distance to this other point. The only way it can move is in a circular form, so that the distance between two of them will be the radius, and that's what you see here. So that the distance between two of them will be a radius. And so this guy can basically just move like this round to form a circle. So that's the idea of a locus. So you see that everything we just did wasn't actually programming, but then we needed to understand the problem to be able to solve it. And in the process of understanding the problem, we stumbled on loci. Now, that is a very important part of programming. Many of the times while you're trying to solve a problem, you stumble on a lot of interesting things that might actually distract you from the current problem. If you give us another few hours, well, I don't know about you guys, but if you give me a few more hours, I would go into loci. I love the idea of loci. They're like very interesting stuff. I will go into it and go and keep going and forget that we had the problem in the first place. So sometimes when you're dealing with problems, you have to do a lot of research about backgrounds, about the problems and all of that. And it can get quickly, what's the word now? Quickly distracting. Maybe a curious mind, which you would naturally be as a programmer. Try not to get carried away, right? So, any questions so far?
All good.
Dami,
Yep.
you have questions?
No, I don't. I don't.
Okay. Ekene? Okay. Ekene is not responding. So that solves our Pythagorean theorem, but I like what you guys did. I think people were trying so many crazy things. Even Obina did something else. Obina went as far as getting me the intercept. But then I don't understand what this was. I was actually hoping he would be online today to explain this formula for me because I didn't get it. But maybe if he gets the chance to upload the video, if I send this to the drive and you want to get more about it, then you can reach out to him. But, I like the fact that he tried to take it further. And like I said, you can get distracted. He's not an engineering person, he's a dietitian, like I said. So he did this in psychology, sure, but he didn't do it as much as, I don't know, engineering guys did it in their GEGs. So I guess he stumbled on them and then he brought by a lot of old memories and he was just going far because I didn't ask for intercepts or slope. But then he got quite curious and then he got, I like that. It shows how excited he is about it. So that's Pythagoras theorem. Amazing stuff, all of you. Thank you for doing that. Gauge calculator. Amazing. I don't know. I was really looking forward to innovative. No, that's not the word. So unusual. Yeah, unusual. I'm not sure that's the word. Shall I get my point? First of all, people that use date time are cheating. Really, that mean that mean didn't just cheat. That mean basically just if you reduce these lines of code, you can write all of these things in like 5 lines. What some people were writing, I think Peter wrote in like let's see, he wrote in 43. If I condense that code well, I'll write this thing in 5. So I'm not trying to say obvious. Matt, okay, no, you're not cheating. Don't let me say anything stupid. You're not cheating, but there's a quick shortcut, a quick one. If you want to know how Dami did this, please reach out to Dami. I'm not going to explain it yet, but it was an amazing way to just put in the user, enter their year, month, and birth. So that it will be perfect. Unlike our code where we restricted it to 1 to 30, you don't have to do that here because the daytime update can recognize them. I think April has 30 days. If you had imputed 31, it will give you an error that this particular month does not allow for 31 days. So a lot of things that Peter tried to do in his own form by checking for greater than 30 and 0, this guy, this guy will do it in 1. So daytime in itself, it's basically a module where all of that is in there. And before I go, there was something that Ekene did that I particularly loved about his Pythagorean theorem. And I think everybody used maths. I don't know whether it was fact of shortcut though. I'm not sure, but I know everybody used maths at least. Ekene did something that I would say was unusual, which was this. It's power 1 over 2. He didn't use import math. He basically used, and I'm assuming that he did this based on his idea of, okay, to solve this problem, how do I go about it? I can't use math of square root. I have no idea what that is. But in square, I remember them telling that square root is power of 1 over 2. And he did exactly that. And I'm sure you guys were taught this in your operator and expression. I'm sure you were taught that when you
right.
Exactly. So he did, this was amazing stuff. I love this. And I mean, if you had just done variables names well, I don't know how you calculated this either. You can, if you are here, please come and explain this to me later, maybe after I'm done with the calculator. But that was good. And the reason why I remember that was because, let me quickly close this. The reason why I remember the whole import power thing, why did I remember it? I'm trying to remember why. Okay, yeah, it's because of this daytime. My natural expectations are we're not going to use any kind of module. We're just going to start working because, like I said, I'm not taught to import. But still, amazing stuff. So this is Dami's code. He basically did, and this was what I loved about Dami's code. Dami, even though he did this here, he converted the age to days. Converted it to days. Now, the reason is because, why did you use int here? Dami, please explain to us, why did you use int? In fact, explain your code to us right now. So I said that like as if I'm going to school if you didn't. Disregard that. Please explain your code to us.
Yeah, the stuff when you use this where I calculated the age, if you try to print it, it's going to give you like the age in terms of I think in terms of hours. Yeah.
Okay. Should we try it out?
Yeah, try it. Yeah, it's going to give you in terms of, it will give you the hours, give you the seconds, give you all those things. So you need to like specify what you want out.
Let's try for 1995. So he printed this out as this.
So it gives you the days and it gives you the hours too. Okay. So and like you're seeing it as string, so you have to convert it to integer. So
you said I say this as a string.
Yeah, if you don't convert the age, just try to like do that age days divided by 365. It's going to give you an error.
Okay, let's try that. 25, 5, 5. It didn't give us an error.
I don't know why, but it actually did that for me. That's why I just like converted it to int. Like let it just be an int.
Okay. All right.
Give me an error though, or maybe I didn't do it. Maybe I did something wrong.
No, it's cool. No, I'm not going to. You're the one that read the code. You're not going to explain it to us. Please go on.
Yeah. So basically, as you can see, it gives you okay. Let me just start from the beginning though.
Should I share my? Should I give you control?
No, don't need. Just let me just continue. Since you have printed the age, the the age part. So it gives you your answer, your age in terms of days and hours. So the dot days part just like extracts the days part of the code and forgets the hours part, and then you divide the days by 365. Although I didn't consider, oh, if we have a leap year, I could have written an if else statement to do that, but there was no need to.
An if-else
Then,
statement.
yeah,
Okay.
there's no need to go that deep. So all I wanted was just print my days. So just when you divide the days, like this 9495 days divided by 365, that will give you like your
26.
yeah in years basically. So
Nice, nicely done. Thank you. So amazing stuff. Dami just explained his code. I want to say Peter should explain his code, but Peter's code is long. Peter's code is long. Peter, how about you explain to us like 1 minute or two?
Okay, so basically, age calculator. So yeah, you just the usual input, your year of birth, the month, and the day. So the condition I put here is definitely because we mentioned that we should use each of the months of the year as 12. So January will be 1, then up to December 12. So I said if the person imputed any number in the month more than 12 or less than or equal to 0, you should print error. And if yours, you should go ahead. So if the person wrote 13 or wrote 0, it will print an error. Okay. And the same goes for the dates. If the person, because since we use the 30-day cycle, so if the person imputed anything more than 30 or less than 0, it also print error. So after doing this, then you go ahead to write the current day, since you want to calculate the age as regards the current day. So if the person, so also in there, you can also see the same conditions. The person has to also follow the same condition as the month and the day between 12 and 30. Then finally, the last condition I used was, I know that like today is 23rd of May. So I know that somebody could be today years old, like probably person was born 1995, and today is his birthday. So if tomorrow is meant to be his birthday and we have today's date, I wanted to take account of that. So that's why I put the last condition where if the month is greater than the month and the day is greater than the day, then you should print that day, else you should print that -1. So you're just trying to tell me that, okay, if maybe my birthday is meant to be 24th of May, 1995, okay, I'll still be a year less than this year's birthday. But if today was my birthday or yesterday was my birthday, I'll be 26-year-old. So that's what my code just did. Yeah. And yes, I also printed the birthday, so you just see it as you go ahead. Yeah.
hello, Taiwo.
Oh shit, my mic was sorry, my mic was mute. I actually thought that it wasn't mute. Can you hear me now?
Yes, yes.
Yeah, we can.
Okay, great. So I wanted to say, okay, so I was born on the 24th of May, 1995, and today is 23rd of May, 2021. What will my age be? I should be 26, bah? And that's what you did here. Amazing stuff.
Yeah.
All right. So I'm missing stuff, all of you. I think everybody basically did the same. They not the same, but like everybody used if and else. This is kind of pretty straightforward. You know, if your birthday is where he basically chose. He had a fixed date, 21st and May 5. So you know, people pretty much use the same thing. If and else, I think okay, they didn't even bother. He just tweeted the age, which is I'm sorry, it's amazing. I think I find this code funny because um I asked that you print out the age and then you print out sorry. Oh god. Let me just show you how it worked. I asked to print out the age. So Sarah was born the 5th of May 1994. Out. If you out the year, the months and the days. Now, this is funny because it seems like man, you couldn't figure it out and then it just gave me the next best thing, which I really appreciate. I don't know why it's making me crack up, but thank you. Um, so like you just give it to you, man. You can't figure out how old you are. I can't figure it out. Okay. All right. More seriously now. Thank you for the codes. So I'm just going to show you what I did. I think I have it here. So I'm going to close all of this and minimize and then open mine. Save that in here. Yeah. So this is my code. 1 minute. Sorry guys, I'm back. Can you guys hear me?
Yes.
Okay. So this is what I did, right? So what basically this does is this was what I was looking forward to. I wanted to see how you guys could use and. When you know how
Yeah,
to
this stuff
use
was hard.
this.
I still use hand in my own shot, but the hand was definitely on hand.
I wanted to see how you would use it without having to use
Use
if
if
and
and else.
else. Yeah.
Yeah, it was hard.
So basically I copied all of this part from Ekene and changed the variable names. So basically the first thing I did was I didn't comment my code. I basically did just like a few minutes before I started the meeting. I calculated the age up until a year before. So at least you know that up until 2021, the current age, everybody has done their birthday. So if you were born in 1995 and it's 2001, at least you are 26, I'll be 25. What's that difference now? Yeah, 25, at least. That's because you did not die as of last year, so you're at least 25. So everybody's birthday is calculated up to a year before the year, which is why I did the -1 year. Right? So everything after is now to check if the person has done their birthday today. Now, the first thing I checked is the current month, is the month that the person put in for their birthday less than the current month? Now, that's why you see is previous month less than the current month. This should give you either true or false. If it is true, that means the person did their birthday in the previous month. If it is false, that means we're either in the current month or a month after. But then that's not all, because even though we're in the current month, it's possible that we've done we've gone past the day. I don't know if you get what I'm saying. Even though we're in the current month, it's possible that the date of birth is still less than the current date. That's the date of the month specific. Do you understand me? Guys, do you understand me?
Try to
Yes, we
follow.
are following. Yeah.
Ekene, please, are you there? No.
Yes, yes,
Okay.
sir.
Are you getting me?
Yeah.
Okay, good. So this would basically tell you, as the person did their birthday in the previous month. So I'm checking is the month that person enters. Say the person enters 6, for instance. Is it less than 5? No, let's not use 5. Let's use 4. The person entered April. That's 4. Is 4 less than 5? True. Okay, so that person has done their birthday in the previous month. Very good. Now, if it's 5 in that case, 5 is 5 less than 5? No. But then it's still possible that the person has done the birthday. That's what we're going to do next. So I check, is it in the current month by saying is the month equals to the, it's basically what the person entered, the same as the current month. That's another option to check. Now, this is where it gets tricky, this line. What this line is saying is that the person has done this birthday if his month was in the previous month or is in the current month and his date is less than the current date. That's it.
That was the trick. So
That's just how you
speak
say the person has done their birthday. If their birthday, remember this will return true if it was in the previous month. So if it was in the previous month, and that's why I put this in a bracket, the current month and the day is greater than the current day. That's all.
So those two conditions has to be met first.
That's this two, exactly.
Yes.
Exactly.
I
So they have to be met first. Now, if it is false, then that means that the person is not doing it that current day. But it's possible that they did it the previous day, and that's why this all is here.
Yes. So this one can choose if one of them is true, then it's still work.
Exactly. Do you guys, Dami and Ekene, did you get that?
Yeah.
Awesome. So great. All I now needed to do, all at this point, birthday don't return true if the person has done their birthday and false if they have not done their birthday. And then what I just did was convert this an integer. A Boolean true is 1. A Boolean false is 0. So if you've done your birthday, add 1 to the age. If you've not, add 0 to the age. And you're done. Did you get that part? Guys?
I think you should just share this with us also, for us to.
Okay. I realized I don't know if the video explained it, but in Python, when you say you convert a Boolean to basically tell you 1 if it's true, and false will be 0. So
0.
instead of having to do if and else again, I just basically convert it to an integer. And then remember I moved the minus one. So it's really intuitive when you see it like this. But so when I was coming up with the solution, actually when I was coming up with the question, my initial plan was to put everything on a kind of say 1 minute. Right. Sorry, I'm back. My initial plan was to put everything on an even scale because this is kind of a how do I explain now? The day is in a unit of days. The month is a unit of months. The year is in a unit of years. I was thinking of, how do I say now? Converting all of them to days. So subtract the number of years of the previous number. How do I say the current year from the year was born? That would be minus 1. That would give you the number of years up until last year. I'll multiply that by 365. Multiply that by 365. That will give me the number of days, right? Then I'll convert months to days. I'll just do that by multiplying by 30. Remember, I could assume that all months have the same number of days. That would be 30. So I have my new converted value of years plus my new converted value of months plus the value of days. And that will give me the number of days the person has been alive. Now do the same thing for my current month, day, and time. And I'll simply just print, I'll subtract them. I'm getting a bit complicated, but just flow with me here. So let's say I had, let me just do that here real quick. So I say year to days will be now here minus the year the person was born, multiply that by 365, month to days will be the now month minus the month the person was born, multiply that by 30. Now, number of days lived, excuse me, will be days plus month to days, sorry, this is day, plus year to days. That'll give me a number of days lived. Now, I'll do the same thing for number of days till now would be basically today is 23rd plus No, these are 5th month times 30 plus we're in 2021 times 365. Yeah, I think. Oh, okay. Sorry, there's a bit of trick to that. If you wait, do you guys understand the new thought pattern I was trying to come up with? Huh?
No, I didn't get that part.
Okay, let me just explain that again. A person is born, you can calculate the number of days a person has lived on this earth without having to use if and else and all that. That's how you calculate the number of days times, change the number of years to days. So if the person has lived if the person was born in 1995, and let's say we're not going to use 2021 as our benchmark because 2021 is still running. Let's use 2020. So between 1995 to 2020, the person has lived for 25 years. Convert that to days. That will give you the number of days the person has lived for, right? That's by multiplied by 365. Now, also take the month. In 2021, how many months has the person lived for? Check the birthday month. The birthday month is, I don't know. Now that I think about it, that's tricky. To do that, you might need to think a bit more. All I was trying to do was convert the person's birthday to the number of days, subtract it from the current number of days, have a value, divide by another thing. It's a long thing. I think this will probably be easier. But if you did get my thought process earlier, I'll probably try to restructure it and send you a script on that one. But if you did get my thought process earlier, then try to code it. That would be great if you can. It's just I'll actually try to see if I can do it. The reason is because I want to reinforce the idea that there are many ways to solve a problem. So compared to what you guys did, this is one way, including the 4 different ways that 4 different ways that I've seen so far. Then I'm adding another way to it. And so, it's really just take your pick. So I'll upload this to the Google Drive. I would try and come up with that tonight and upload that to the Google Drive as well. And then you can have your feel. All right?
Okay, great.
Okay, so I think that's all the questions. That's all the things I have to share. Yeah, that's everything I have to share for now. Okay, I think when I was running Ekene's code, I ran into something which is basically complex numbers. It's possible that when you're testing your code, you will run into complex numbers because obviously you're finding the square root of numbers. If you don't know the values that you're entering properly, like if you've not actually solved it on paper and you're not getting an actual number, you're just entering random value, you'll probably stumble on, at some point rather, your code will want to calculate the square root of a negative number. And then the code will throw an error telling you that it's not possible to do that. Now, yes, it's not possible to do that, but we all know that mathematically you can find the square root of a negative number by using complex or whatever. To use complex here, you have to use something else in a math module. I think there's something called I, like there's a literal thing called I, complex numbers, Python. Yeah, I think there's something called I. Let me just try 6I. No. I can't remember. I've worked with it before. So
I think
if you
it's G, like 6 plus something J.
Oh yeah. Sir?
I doubt. Okay, it works. It works.
It works. That's it. So if you ever encounter complex number problems, this obviously shows that Python deals with that. Now, before I conclude, does anybody have any questions? This is the point where you say yes or no.
Okay.
Okay.
I was going to say that Pythagoras theorem, I didn't get the conclusion though.
Okay. That's the length of diagonal bar.
Yeah, you said the length of diagonal is like the length of the line.
We explained that here. Let me quickly run through it one more time for you, back. I say back.
Wait.
What am I saying? I keep saying back these days. Sorry, you were saying?
Yes, I was going to say the length of the diagonal, is it not drawing a line from points, let's say this point X, okay, this X on points Y1, Y2 down to point X3, X3, X4.
Like this bar?
Yeah.
Okay, yeah. So
Then the other
that's
one too.
act. Okay. I explained that before you came. I think that was just before you came on board. That is a diagonal, yes. It is in
Yeah.
the sense of it. But if you did mathematics, diagonals do not actually exist for open-ended shapes like this. Parallel lines do not meet. So they're not enclosed, like triangles or pentagons. Those ones have diagonals because they're enclosed. Basically, this is the diagonal of a pentagon of a triangle of a rectangle rather. But for a parallel line, it doesn't have a diagonal because at no point will it meet. So there's no way of drawing corners, lines from the corner down to the other corner. If somehow we're now talking about, okay, we had a parallelogram, such that it was, this is not a parallelogram, this is a kite, I mean, what they call them? Yeah, this is a parallelogram actually. I don't even know again. Sure, I didn't mean this
Yeah.
was enclosed. Then a parallel line going a diagonal going from here to here would have been an actual diagonal. But then when you're dealing with parallel lines, they don't actually meet, so they don't have diagonals. In that case,
Yeah, that's true.
I should have explained that on Wednesday. What I wanted you to get from me, but I actually wanted you to do some research and find out because I wanted you to understand the importance of research as well. What I wanted you to do was to draw a line that was like 90 degrees perpendicular to both of them, draw it in two places. The diagonal between the two lines such that the ones that goes from this corner to this corner. You get that?
Yes, yes.
So, you know, even me, I'm not even sure what I'm saying. See, I'm not a
Yeah,
mathematician.
that's
I'm a
correct. That's
programmer.
correct.
So, just try and figure it out. I'm sure it will make sense eventually. So you
Yeah, I
notice
guess it's
that.
correct.
Thanks. I'm not okay, well, thank you. You notice that if you move it, no matter how you move it, it will be the same. You see that? No matter how you move it, it will be the same. So the question is, how do you get this diagonal? How do you get this length? That's where the wahala day. That's where the wahala day. Does anybody have any idea? How do you get this length? Because obviously we can't take random points. Do we just take random points on that lane? And if so, how exactly do we know where the random points are? So how do we get this length? Any ideas from your understanding of geometry and all of that?
I think you would have to use angles now.
Angles, okay. Can you explain
Yeah.
that?
Not so sure. Okay, no, it won't
Can
work.
just use the coordinate and perpendicular. Like if you
What's
can get
coordinates?
perpendicular to one, like you could pick any point. Like
Okay.
assuming now because we have at A1 now we have coordinate x1, y1. You can pick that part and get perpendicular to that particular line. You get. I
So
know
you want
there's
to
a
get the
formula. I can't
perpendicular
remember it
line.
mathematically.
You want to get the
Yes,
perpendicular line between A1 and A2, right?
yes. You are not going to get perpendicular. I can't
Okay.
just
Okay.
remember. But yeah, there's a stuff where you can get a perpendicular line using a coordinate.
Yeah, there's a formula for that. You can get the slope of a perpendicular line to another line by going M1 equals to 1 over minus 1 over M2. Let me just show you that real quick. Getting slope of perpendicular lines. Yeah. M1 times M2 equals minus 1. I think that's the formula for it. So you just do some divisions and then you're good. Okay, this is an equation. So that will give you the slope. From the slope, you can get the equation of that line. Then if you get the equation of this line, what else do you need to get the distance to get this length of diagonal? If you get this equation of this line, what else will you need to get the length of diagonal? You can get the point at which they intersect. This gets tricky and getting trickier and trickier. There's a word like that. So what I'm
That's
suggesting is this.
it's
I'm
the
sorry.
right angle triangle. So I still feel like you'd have to use angles too.
Ultimately, definitely, but to get the right angle triangle, that's this guy. Use Pythagoras or not. You need to know this coordinate points. At least know the distance between the two
Yeah,
parallel
one part.
lines.
Yeah, one. Yeah.
So I'm guessing you can think about it also. I'm just going to say a rough solution would be, like Peter said, find the perpendicular line to either A or B. It's very possible to do that. again, because they are parallel, the perpendicular line will be the same. So if you get the equation of the line perpendicular to A and B, they will be the same. Now, if you get another, sorry, excuse me. Now, find the point at which they intersect. Find the point at which they intersect. You get at this point. I'm sure there's a formula for that. Then you can now use this as your reference. Let me shift this to the bottom. Let me do this here. I'm going to shift it to the tip. We know the coordinates of this point. If you find where they intersect, you can then draw a line like this. We already know the coordinates of this point as B2. We know the coordinates of this point as B1. Now, if we can find a perpendicular line to this, I told you there's a formula for that. We can get that to be C. There's also a formula to find the point at which this perpendicular line and A intersect. You can call that C0 or whatnot, C0 or whatnot. Now this will give you the point at which they intersect, x1, y1. This will give you another x1, x2, y2. Now if you delete every other thing on this surface, so let me not delete this one. Delete every other thing, you have 2 points, B2 and C0. How do you calculate the distance? Your normal Pythagoras theorem already that you know. X1 plus x1, x2 minus x1 squared plus y2 minus y1 squared, all square root. Did you guys get that?
Yep.
Yeah.
So basically, I'm running you through my process because I'm trying to show you. So now that I think about it, I'm thinking that this one might not actually be what I intended. This is just coming to me now, so I'm sorry for that. But it's an happy coincidence because now you understand what it means to think through a problem. You're able to calculate the distance between this line, which is good. If you were to develop a paint package, for instance, a graphic design package, and then you needed to start doing all these calculations, it should be easy for you. So what I just did was to show you how to think through problems like this. If you ever have the time during the week, you can go online and just play around with problems. I'm going to close this. So before I conclude, any other questions? This is the point where you say yes or no.
No.
Okay, so
None from me. Thank you so much.
awesome, you're welcome. I'm just going to say this before I leave. This part that we just concluded is an integral part of programming. Peter can probably testify to this. When we're dealing with mechanical project, we had to do a lot of mathematical modeling. And if you know, because those mathematical models are just formulas, some can get complicated really fast, some are not. But then if you know how to properly represent a mathematical model in real life, in your code, then I mean, you've done like 1/3 of the problems already. Like generally speaking, most programming problems are usually replicating some kind of real life scenario that is guided by a mathematical model in your code. Now, when you deal with artificial intelligence and machine learning, actually I don't know a lot about it, but I assume they're also based on mathematical models. Now, I taught you this with the intent that for most of the assignments, you already had a formula in mind, and you basically just coded your formula. Somebody told me, I think it was Peter's code. Let me see if I can show you that. It was in Peter's code that I saw this part where it says it tested for parallel lines. Now, I'm just going to comment this part out. Now, assuming I taught you a package called graphics, I taught you how to draw graphics on, say, Python. You can actually modify Peter's code such that it will show you one tick line, call that the reference line, and then it will show you, it will just basically be checking different lines around that reference line to see which one is parallel. That's essentially what this code does. It's just that you can't see it because there's no graphics to it. But if I included the graphics, if I included the graphics so that there's one reference line, let's call that line A, and then I just start to show different lines until I find the one that clicks, and then it stops. That will give you a very good idea into what a lot of the math, not our basic one that we're taught in school, a lot of the stuff we do online, sorry, a lot of advanced maths, if you did, I've forgotten what they call them, binomial expansions or whatever, that you have to run iterations over and over again until you find the one that is closest. Now, that is when you're now going to see what it really means to be able to replicate your mathematical model in your code. And we're going to talk about that when we get to loops, because most of those stuff require loops. So we're going to talk about that when we get to loops. We are definitely going to do an assignment. Let me just give you an idea ahead. When you get to loops, you're going to write a code that will calculate the square root of a number. You're not going to use math.power. You're not going to use math.square root. You're not going to use any of that. You're going to use some laws, some binomial expansion laws to get the value. So essentially, this guy gives you a lot of options. It gives you a lot of tools. By the time you mix that with these two, the sky's the limit. All right. So with that said, I'm going to send materials for the if and else statement tonight, if I still have the time. I'll send the codes, everything I did, the one I did, the one you guys did, I'll send to the group. I'll try and create the other idea that I had and send all of that to the group, and I'll notify you guys once it's done. I'll send the assignments tomorrow. We'll have a meeting on Wednesday, and hopefully this week we'll actually do our code review on Saturday. Or do you guys prefer Sunday?
I think Sunday is fine.
Sunday is
cool.
Saturday.
Okay, this Saturday. All right. Maybe we'll take a vote when the time comes. All right.
The Champions League happening on Saturday.
Wait, is it this Saturday or every Saturday?
Saturday.
Just this Saturday then?
Yeah, the final.
Oh, okay. I know Ekene and Peter and Peter and Dami, they watch ball. No, no, personally I don't watch. So if you want me to do it, I'll do it.
I do watch.
It's cool. It's all right. No problem. I will probably do it on Sunday again. So that'll give you more time to be able to do the assignments. Just try not to get too, for the lack of better words, depressed whenever they beat your teams or whichever team is playing on Saturday. Nobody should mock me because I don't know it. All right. All right, guys. Take care of yourself. It was nice. It was a long one, but I appreciate that you stayed up to the end. Thank you very much.
Thank you so much, everyone. Have a good week.
You too, man. Cheers.